Now that we've defined what a sampling distribution is, I want to point out one of the key properties that we talked about in the previous video. This is something that you're going to use throughout the rest of this class. And that is, if the population distribution is normal, then the sampling distribution of the sample mean is also always normal, regardless of the sample size n. So when you're working with these sample means, your first stop is to look at that population distribution and decide, is it normal or not normal? So if it's not normal, that's something we'll cover later on in this chapter. But if it is normal, then the sampling distribution will also be normal for any sample size that you want to use. And so our sampling distribution then is going to be distributed normal. So we have an n, and then I'll have the same mean. The only thing that's changing here is the standard deviation. And the standard deviation is being divided by the square root of n, or the sample size. All right, so let's look at an example. The 2012 American Time Use Survey contains data on how many minutes of sleep per night each of 12,443 survey participants estimated they got. The times follow a normal distribution with a mean of 528.8 minutes and a standard deviation of 137.2. From this group of 12,443 participants, samples of 100 people are randomly selected and a mean is calculated. All right, so the population here, because they're pulling the samples from the American Time Use survey data, our population is the 12,443 survey participants that are in that survey. What values does the population distribution describe? That'll be the minutes of sleep for each of the individuals that are in this sample. And that makes our population distribution N for normal, 528.8 and 137.2. So that kind of takes care of the population side of this example. Let's look at the sampling distribution. So suppose a simple random sample of 100 participants is polled and it has a mean of 509.23 minutes. They pull another sample of 100 participants and that one has a mean of 530.32 minutes. They repeat this process over and over again, and after many simple random samples, the many values of the sample mean follow a normal distribution with a mean of 528.8 and a standard deviation of 13.72. So what values does the sampling distribution of X bar describe? It's going to describe the average sleep time for the 100 individuals in each sample that was polled. And then our sampling distribution here is normal, 528.8 and 13.72. So we originally had 137.2, now we have 13.72. And they got there by dividing by the square root of 100. So that square root of 100 is 10, and when we divide that, now my sampling distribution has a much smaller standard deviation.